Hello everyone, welcome to my vlog, and in this video we are going to talk about understanding the graph of a polynomial function. This is actually the second part of our topic, illustrating polynomial functions. If you can recall, our first part is all about getting the degree, leading coefficient, and the constant term of our polynomial function and also transforming it into its standard form. So are you ready for this topic? But before that, if you are new to this channel, please hit the subscribe button and hit the notification bell to get notified whenever there is new video coming. Okay, so let's begin. So to begin, I have here a graph of the polynomial function fx is equals to x to the power of 4 minus 10x squared plus 9, or in factored form, it is f of x is equals to the quantity of x plus 1 times the quantity of x minus 1 times the quantity of x plus 3 times the quantity of x minus 3. So basically, these two functions are just the same, though it looks different. Okay? So, let's go back to its graph. So let's try to connect the polynomial function and also its graph. So first, as we have observed, we have here some points. This one, this one, this one, this one, and this one, and this one, and this one. Why do you think it's emphasized? Because it would tell us some important parts of the graph. So for this one, okay, with a colored blue, this one, these points are actually called turning points. Why they are called turning points? Because it is where the direction of the graph changes, right? So from here down, it changes going to up, and then from up it changes going down, and then it changes going up. So that is the point where the graph changes its direction, and it's called turning points. And aside from that, this point here, which touches the y-axis, or actually passes the y-axis, it is called the y-intercept. Okay, so if the graph crosses the y-axis and the point which is hit by the graph is what we call the y-intercept. And y-intercept is actually the constant term of the polynomial function. No? Diba? Here, the point lies in negative 9, 0, negative 9. So if you try to recall the ordered pair, no? So this point here is 0, the value of x, and then the value of y is positive 9. Okay, so it is the constant term if you try to look at diba? So that's it. And the points here, which is negative 3 comma 0, remember, and the point here that is negative 1 comma 0, then here is positive 1, comma 0, and 3, comma 0. If you want to ask me what this point is, it's actually from x-axis, that's negative 2, and then from y-axis, so that's negative 15. Okay, so here this point is actually from x. So just to refresh how to name the points, and this is negative 15. So this is for x and this is for y. Okay, so now going back to this point here, that's negative 3, negative 1, 1, and positive 3. So if you try to look at the given polynomial function, where can you see that? It is here, right? In the given factored form. No? So these points are actually called the zeros or roots of polynomial function. No? And to get the zeros and roots of the polynomial function, it is easy once it is already in factored form. So for example, this one, we will get the first factor, x plus 1 is equals to 0. When we say roots or zeros, it is the time when we equate the function into 0 because y is equals to 0. So x plus 1 is equals to 0, and to get x, we have to transpose plus 1 to the other side so that x will be the remaining entity. Okay, so if we transpose, we change the plus into minus, so it becomes minus 1. Okay, so that's why we get negative 1. How about this one? X minus 1 is equals to 0. So transpose. So x is equals to, from negative it becomes positive, so that's why we have positive 1. And this one, x plus 3 is equals to 0, so that's x is equals to negative 3. So that's y. And then for this one, it's this one. No? So you know already how to do that. Okay? And other name for that is also x-intercept because it touches the x-axis, or it is where the graph crosses the x-axis. Okay? Okay, so again, the points where the direction of the graph changes is called turning points, and the point where the graph touches the x-axis is called the y-intercept, and which is also equal to the constant term, and the zeros or roots of the polynomial function lies in the x-axis. So these are the points where the graph crosses the x-axis, and it can be seen from the factored form of the given polynomial function. Okay, so now let's have another activity, and this will help us identify the relationship of the degree and the turning points of the polynomial function. So now we are using here the term turning points. That's what we learned a while ago. It is where the direction of the graph changes. So from this picture, we have a polynomial function having the degree. So if you say degree, it is the highest exponent of the variable x, no? If we are using variable x. Okay, so the highest exponent is 1. We will call it the linear function. If the degree is 2, we call it quadratic function. If the degree is 3, we call it cubic. If the degree is 4, we call it quartic. If the degree is 5, we call it quintic. And if the degree is 6, 7, 8, 9, 10, there's no name for that yet. Okay, so you'll just call it polynomial function as its general name. So again, now let's look at the graph, because we are going to identify the relationship between the degree and the turning point. So from the graph, if the degree is 1, is there a turning point? Diba? The graph does not bend. It just goes straight. So there's no turning point. So it means the turning point is 0. If the degree is 2, yes, definitely there is. That's 1. If the degree is 3, 1, 2, there's 2. If the degree is 4, how many turning points? Okay, there are 3. If the degree is 5, how many turning points? 1, 2, 3, 4. So there are 4. So what do you think if the degree is 7? How many turning points? That's very good. 6. If the degree is 8, how many turning points? That's 7. So what do you think is the relationship between the degree and the turning points? So the relationship is the turning points, or the number of turning points, is actually 1 less than the degree, no? 1 less than the degree. So meaning the turning point is degree minus 1. It's 1 less than. So let's see. If the degree is 2, so it means the turning point is less than 1 of it. So that's 1. If the degree is 3, that's 2. If the degree is 4, that's 3. And so on and so forth. So do you have any question? You got it? Okay, so let's summarize our topic. Okay, so the polynomial function graph has what we call the turning points, which is the direction. It is where the direction of the graph changes. And also, there is what we call the y-intercept, wherein the graph touches or crosses the y-axis. And y-intercept is also the constant term of the polynomial function. And we also have the zeros or roots of polynomial functions, which can be seen from the factored form of the given polynomial function, and these zeros and roots lies in the x-axis. So these are the points where the graph crosses or touches the x-axis. So those are what we call zeros or roots. And the relationship of the degree and turning point, the number of turning points is 1 less than the degree. Okay? Okay. So do you have any question? I hope you have understood or learned something in this video. So that's all. And again, if you are new in this channel, kindly hit the subscribe button and the notification bell so that you will be notified when there is new video uploaded. And you also share this video to others who might be needing this kind of topic. Thank you once again and love lots. Bye bye.